Next, we give the INSAP address for this router. This is going to be done with the net command. We say net, and the first portion of the INSAP address, as we discussed earlier, can be an AFI. A locally administered AFI is going to be a 49. That's what we'll use. We'll say net 49 dot. The next 4 digits represent the area of this router. Router R1, we're going to associate with area 100. We're going to say 0100 to represent an area of 100. Next, we need to give 12 digits that are going to represent the system. And these 12 digits could be 12 digits from a MAC address on one of R1's interfaces, or what I prefer to do, I prefer to use the IP address of the loopback interface. For example, we have an IP address on our loopback interface of 1.1.1.1. What we can do is represent each of those octets as 3 digits. In other words, 001, 001, 001, 001. That's 12 digits. And it represents our loopback interface's IP address. So let's do that. Oh, and by the way, we should put a dot after every 4th digit. However, for me, it's easier to type everything in first and then go back and add the dots. Let me show you what I mean. Let's type in 001, 001, 001, 001. Now, for me, it's easier to type everything out like that and then go back and insert a period after every 4th digit. And finally, we're going to add the N selector, which is always going to be a 00 for a router. Well, we're done initiating the ISIS routing process on R1. Now, let's go into our various interfaces on R1 that are going to be participating in ISIS and tell them to participate in ISIS. Oh, and by the way, here in router configuration mode, we did not give this command. We could have said IS type, and we could have said that R1 was a level 1, 2 router. However, that's the default. So no need to enter that here on router R1. Let's go into interface loopback 0, and we give the command IP router ISIS to say we want this interface to participate in the ISIS routing process. Next, we go into fast Ethernet 0/0. And we say IP router ISIS. Same thing for our 2 serial subinterfaces, serial 0/0.1, IP router ISIS, and serial 0/0.2, IP router ISIS. We're done now with our initial configuration on R1. Let's move over to router R2. Again, we go into global configuration mode. We start the ISIS routing process. We give a similar net command. Here we say net. We give a locally administered AFI of 49. This time we are in area 200, so the area is going to be represented by 0200 dot, and R2 has a loopback IP address of 2.2.2.2. So let's use that as our system ID. We can say 002, 002, 002, 002, and then I'll go back and put in the dots after every 4th digit. Finally, we give a couple of zeros for our N selector, and we've initiated the ISIS routing process on router R2. And just like we did on R1, we now want to go into our various interfaces and tell those interfaces to participate in ISIS. Let's go into interface loopback 0, and we say IP router ISIS. Let's do the same thing for interface fast Ethernet 0/0, IP router ISIS, and the same thing for interface fast Ethernet 0/1, IP router ISIS. I think we're now done with our initial configuration on R2. Let's move over now to router BB1. On router BB1, let's get into global configuration mode, and let's say router ISIS. Let's give a net command using our strategy as we've already illustrated, 49.0100, because we're in area 100. And for the system ID, we have a loopback IP address of 3.3.3.3. So let's enter 003, 003, 003, 003, and insert a period or a dot after every fourth digit position. And we give a 00 as our in selector. One other thing we want to do on BB1 that we didn't do on R1 or R2, we want to say it's a special type of ISIS router. Specifically, this is a level 1 ISIS router. The default type is level 1-2, and that is the type that we have for R1 and R2, so no need to configure that on those routers. However, BB1 and BB2, these are level 1 only routers. So we're going to say IS-type level-1. Now, as we did before, let's go into our various interfaces and enable the ISIS routing process. Let's say interface loopback 0, IP router ISIS. Let's go into interface serial 0/0.1, IP router ISIS, and interface serial 0/0.2, IP router ISIS. And we're done with our initial configuration on BB1. Just one router to go over on BB2. Let's say in global configuration mode, router ISIS, and let's give a net command with an AFI of 49. We are in area 100, and we have a loopback IP address of 4.4.4.4. Let's insert the periods after every fourth digit, and we give an in selector value of 00. This router, like BB1, is also a level 1 router. So we follow this command up with IS-type level-1. Next, we go into our interfaces and say that we want them to participate in ISIS. For loopback 0, we say IP router ISIS, interface serial 0/0.1, IP router ISIS, serial 0/0.2, IP router ISIS, and we're done with our initial configuration. Now, let's go back over to router R1 and see if R1 has knowledge of all the different networks in this topology. Back on router R1, let's issue the command show IP route. And a couple of things to notice here. Notice that the networks available off of R2, which is in a different area, they show up as ISIS level 2 routes. You see this for 2.2.2.2 and also for our 10.1.2.0 network, which is hanging off of router R2. Those show up as ISIS level 2 routes. They're outside of our area. However, networks available off of BB1 and BB2, which are inside our area, they show up as ISIS level 1 routes. You see this? 3.3.3.3, 4.4.4.4, and 10.1.1.0. Those are all level 1 routes learned via ISIS. As our next step in this lab, let's add authentication. Specifically, let's go into the interfaces interconnecting R1, BB1, and BB2 and enable authentication. This is going to help prevent unwanted ISIS adjacencies.